Let's talk about static polymorphism. It is very simple actually. We already know that it is done only within classes, abstract or concrete, or interfaces. And the other thing to know is that it happens during compile time, which I will explain to you in just a minute. Let's imagine that we just got a new business requirement for a developer base class, stating that we need other methods of coding. One method will take in an additional development language besides the primary, and the other method will take in 2 additional development languages besides the primary. And as you have already guessed, for each method, we would need to display a different message stating that we're using those additional development languages. So we can do this without static polymorphism. We could just do this by using conditional statements. So let's go ahead and skip static polymorphism and just use good old-fashioned if-else statements. Let's do that first, and then we will clean up our code afterwards. So I will go to developer, and here I will just pass in 2 parameters. String first extra dev language and string second extra dev language. All right. And here are some conditions. First of all, we're going to make these optional. So we're going to say if nobody passes in first extra dev language, then just set it to null, meaning set it to nothing. Same thing, do it for the second extra dev language. Now we're going to say if first extra dev language is basically null, and second extra dev language is null, meaning that nothing has been passed in, then what we're going to do is we're going to just print the regular message which we had before, which is just printing the primary message, right? Next condition is going to state if we have both of them set to something. So if our first extra dev language is something, so it's not null, and same thing goes for our second extra dev language. So if they're both set to something, what we're going to say is the following. We're going to say, here we go. We're going to say I'm coding using my main dev language. Additionally, I am using the first extra and the second extra languages. So additionally, I'm using whatever it is that's going to be in there, and the second thing that's going to be in there is extra dev languages. Great. Now let's pop them in there. So first extra dev language, second extra dev language. By the way, this is not this. That was my mistake. So it's just a parameter coming down from here. It doesn't belong to the class, so don't need a this for that. First extra dev language, second extra dev language. That's all we need. Now, a few more conditions. I'm going to go down and continue those on. So I will say first extra dev language is not null, meaning that if both of them are null, then this is what's going to happen. If none of them are null, everything is passed in, then this is what's going to happen. If only the first one is passed in, then I'm going to say I'm coding using my main dev language. Additionally, I'm using that, whatever it is, as extra dev language. So I'm just going to say first, and then this is going to repeat. The same exact thing is going to repeat for the second one. And the second one is going to say second extra dev language. I'm using that as extra dev language. So that's it. And for this one, the condition is going to be different. So we're going to say if the second extra dev language is not null. Okay? As you can see, this is not very clean. Firstly, using if-else statements is not the most preferable way to go unless you have to. The reason is because the code becomes harder to manage. In our case, it is a very simple requirement. But if there were more parameters, this could get pretty ugly, which would be hard to read and maintain. Before anything, let's instantiate our web developer class and test out our code method. So I could have also instantiated the software developer, but web developer is already here, so let's just go with that. Remove this, keep it simple and clean. Okay, we don't need develop in this example, so I'll just say code. Okay, this works. What if I set code with an additional language of C#? Let's say they're working on web API. That works as well. And if they are working on web API on the back end, and let's say front-end HTML. So that works as well. But here's another thing. We can also do things such as this. Or we can just pass in something that's null and then also have the second language be HTML. I mean, what this is going to do is it's going to do the same thing as this, because we are checking here to say if the first language is null, which in this case, if both are null, this is what's going to happen. If none are null, this is going to happen. If first is not null, then that's going to happen. But if this fails, then it's going to fall back on this guy, which is second extra language is not null. And then it's going to do the same message, but just for the second extra dev language. So we can actually run and see that that works. And I will go ahead and do just that. So go through this, just says I'm coding using my main dev language Angular 6. Second one, additionally, I am using C# as extra dev languages, it says, which we can just change. It's just a verbal thing. And for the second one, it says I'm using C# and HTML as extra dev languages. Cool. And then last one is I'm using HTML as extra dev language. So it's a singular, but still, you know, we have this weird thing where we can just pass in a null and it treats us as a single extra dev language pass. So it's actually, let's go. One thing we want to quickly fix, say language as extra dev language and language. Cool. So that's just kind of a quick fix there. And as we can see, we have successfully satisfied our business requirements. However, on the back end, the code is not the best. So here, the code is not the best. Just looking at this, which is a very simple solution to a very simple problem, it already looks cryptic and you have to read through the entire thing to understand what it means. Also, there is a lot more room for error. For example, if you messed up the order of your conditions and bring the second one all the way to the end, then the whole thing will start to malfunction. Let's try it. So for example, if I take this and put it at the bottom, right here, now this will not function properly anymore. Let's see why. If I don't pass anything as my first extra dev language and I don't pass anything as my second extra dev language, fine, sounds good. The first condition will work just fine. It'll print the default message. Then what's going to happen is if I pass both of them in, so I have first extra dev language and I have second extra dev language, then guess what? It's only going to check the first condition. It's going to say, is there a first extra dev language? Cool, sounds good. Then just go ahead and print this. It'll won't even hit the last condition, which would actually check for the second extra dev language and print this message, which would be the proper response. But since you're mixing up the conditions, it's very easy for this code to break. So if I was just some person and rewriting this thing and I wasn't very careful, I could have easily broken the functionality. So you can see that this is very fragile, right? So we can actually go ahead and try that and we'll see that this is malfunctioning now. We'll run that thing, give it a second and see if we go here. First one works. Second one says I'm using C#, great. But then see the third one, it says I'm using C# as extra dev language, but it's not really taking into consideration the fact that we passed in HTML. And the last one works properly because it says, you know, the first one is not there, so I'm going to go to the second one. But the case where we're able to pass in two languages, that just broke. And that's because it's easy to break this code. It's not very readable and maintainable. So if somebody was to refactor it or rewrite it, there's a higher probability that they would break it. Now, the entire complexity and bad readability can be avoided if we use static polymorphism. Let's check it out. I'm going to go ahead and I'm going to say this. I'm going to basically pass in the code here. And it's virtual. That's cool. It's not going to have any additional or optional rather parameters. For the one where it's both of them passed in, this is the message. I'm gonna cut and paste it right here. So that's that. If this doesn't have any parameters, we just want to keep it to the original. So by the way, see, I have the same signature, so it says you cannot have the same method. But if I take it out, see, okay, so that's, I'm able to make it work if I have different parameters. We'll talk about that just in a few seconds, but I'm just going to write the code first. So this is the case where we're using the primary language, and then what's going to happen is right in the middle I'm going to put one where we only have one extra language, and in this case I'm just going to change the name of the parameter extra language, and I'm going to grab this guy, and we don't have to repeat the code as well. Just pop it in here, extra language, boom, and that's it. Take the whole thing out, and here we go. As you can see now, I have the same name method, which is code. However, I'm passing in a different variables inside. So different parameters, or different amount of parameters. This is what I meant when I said that static polymorphism happens during compile time. We're basically determining its different behavior as we're writing our code, not while the code is running. Isn't this much cleaner and much more readable? Of course it is. There's not much room for user error, and if anybody else rewrites any of these methods, none of the conditions would be accidentally messed up because the code is a lot simpler. And we're also not repeating ourselves. Also, this is what I meant when I said that a component can have the same form but different behavior. So in static polymorphism, as we have mentioned, the component is the method. So it is on a method level. In our case, the method is code, and the signature of the method is exactly the same, except the parameter it is taking. And that is what determines its different behavior, which then will allow us to use static polymorphism as an OO feature, or object-oriented feature. So once again, the name is the same, it's code. Type is void, it's virtual, public, everything is the same, except the parameters that it's taking. This one is taking 1, this one is taking in 2, this one is a string, and this one has 2 strings. So one more thing, the way you can differentiate methods from one another is as follows. You can have different amounts of parameters, which is what we have currently. We have different amounts. So this has nothing, this has 1, and this has 2. You can have the same amount or different amount, but different types of parameters. And you can have the same amount or different amount, but parameters put in a different order. So I'm just going to quickly demonstrate that. For example, let's say this had another parameter and it's extra dev language 2, just for simplicity's sake. I'm not going to keep it here, so that's the reason. See, I can't have it here. Why? Because the signature is exactly the same. This now has parameters that are 2 strings and 2 strings. So it doesn't know how to differentiate. But if I take it out, then it knows. So that's how we're just relying on the different amount. But the types were the same. If I change this into int, that's a different type. Now I can still differentiate it, and that's cool. But if, let's say, this guy was also int, that would not work. However, see, right on the line, however, if I was to change the order of it, then it would work again. So it's the 3 ways in which we can differentiate it: the amount, the types, and the order in which they're placed. Okay? One thing is, it's actually not recommended to differentiate your methods based on the order of parameters because it makes your code very confusing. So just try to rely on the amount of parameters and the types of parameters. So I'll actually bring this back to its original state. Here we go. Now let's actually look at the program. Here we go. As you can see, nothing has changed and everything is working just fine. So the way we have instantiate our method is exactly the same, and the way we call code method is also exactly the same. However, on the back end, we're using static polymorphism in order to clean up our code. Also, this last one is not a weird behavior anymore, because with this, all we're saying is that the first language is null and the second language is HTML. But this method will still hit this guy, which is first extra language and second extra dev language. It's much more intuitive. Whereas in the other case, you're passing in 2 parameters, but it's treating it as if you were passing in only one parameter. So it's just confusing. But in this case, if you're passing it as null, it just says that, hey, I just don't have that programming language, so I'm not going to show anything. So if we actually run this, you'll see what I mean by that. If we go here, first one works, second one works, third one also works, C# and HTML, and the last one, see, it just says I'm using, there's empty space, it's null because it doesn't know what to write. I mean, it's just an empty space, and HTML has extra dev languages. But it's much more intuitive because when you're calling the code method and you're passing in two things, whether it has null in it or it has two parameters, you are expecting that this is the message that's going to come back, instead of it making some strange assumptions in the back end and treating this case the same as this, just because we're using conditional statements and getting around the problem in a hacky way. Or in other words, as I've already said many times, we're trying to fit the square peg in a round hole. So this is it. I will go back to the developer, see, much cleaner, and that's it. In our next video, we will talk about dynamic polymorphism.